Thank you, man. Guys, Sophia, this is recording. We can hear you whisper in the video, can we not?
Oh.
I have never looked at any of the videos I have posted online.
You haven't?
I have never looked at one. If I look at it and I see that this guy is exploding my face, I'm gonna take him off. Right?
It's okay, you always try to cover your face anyway.
I always put a what?
Your collar looks really nice in the video.
My what?
Your collar.
Collar? This?
Yeah, the color of your skin.
No, collar.
My rosacea.
No. We got a treatment for that, my house.
The treatment doesn't work. Here is an alkene. And if we add chloroform, CHCl3, and potassium hydroxide, what we are going to get is something called a carbine. The product will be something like that. The product is going to be a cyclopropane. So you see, this looks like an epoxide, yes? Remember last week? Did we treat this with MCPBA or no?
Yes.
I forgot.
Yeah, we do.
MCPBA, and it gave us
Epoxide.
Oxymercuration or an epoxide, yes? This is a carbine. Okay? We can also do a similar reaction. You guys want to know the mechanism for this?
Yes.
Yes.
Do we need to know it for the tongue?
Well, I just think it's a nice one, so I give it to you, I put it on the test. If I don't do it on the board, then you don't have to know it.
No, we don't.
We want to know it.
It's too late, you already had the chance and you said yes. And the other one is CH2I2, zinc and copper. This is still a carbine that will form what? Still a cyclopropane. This will add to the same face of the double bond. What's the difference between the carbene on the top and the carbene on the bottom? Okay, carbene on the top has 2 chlorines on that carbon, and carbene on the bottom
Has 2 hydrogens.
2 hydrogens instead. Okay, you have to know those reactions for the test. Now, I did not give you reactions that are synthesis of alkenes, yes? I did not give you reactions in which we make an alkene. I just gave you reactions of alkenes, yes? We are going to do, even though they're in the book, we're going to do those reactions that produce alkenes when we do eliminations. Okay? We were doing alkynes before. Where were we?
Keto-enol.
So we added HBr to this.
Yes.
And how about Br2?
Yes.
And we did
AgSO4.
AgSO4. What is that for?
Hydration.
But for what does that give you? It gives you that's for terminal.
Tautomerization.
That is for terminal alkynes, okay?
Mm-hmm.
That is for terminal alkynes. Did we do hydroboration?
No.
No. Hydroboration?
No.
No.
Not for the alkene.
For the alkenes, no, for the alkynes.
Yeah.
You guys forgot already how to pronounce this in the German way.
Hydroboration.
All right, so let's say we have this then. What else is hydroboration?
Oxidation.
Huh? What else is hydroboration? What else are we missing?
IH2.
Is that?
IH2.
No, yeah, that's for sure. I don't have to know it. You guys remember that, yes? I do not have to know this.
Oh, yeah.
Because
H-
I'm not
H2O.
going on the
H2O,
test.
peroxide.
H2O2, comma OH.
It's impurity, so it's gonna be H2O2.
So you see, whenever we have a test, I am not going to feel bad when you fail, because I have been giving you an opportunity to study and you have it. Thanks for coming late. What is this for? What type of reaction is this? Hydroboration, oxidation? And what does it give you?
Anti-addition. Anti-addition? Oh, no, wait, I'm on the, oh, sorry, I'm on the wrong one. Sorry, I was at H2O. An alcohol. I'm sorry. I'm sorry, I was looking at the wrong one.
All right, well, I live with disappointment.
Are you asking for like, is it a sin addition?
Here is, no, I'm
Is there
asking you,
H-
what is the
H?
product of this reaction? What is the product of hydroboration oxidation?
H2O.
Huh?
For alkenes, it gives you an alcohol.
H2O. It's a sin addition. H2O. It's sin.
I'm asking you what the product is, I'm not asking you anything else. The product of hydroboration oxidation is an alcohol, yes or no?
Yeah.
All right, so I am going to put a hydrogen on one side and an OH on another side, yes or no?
Yes.
The hydrogen is gonna go where? This is not
Anti,
bad.
the one that has less carbon.
With the.
It will go Markovnikov
It's-
addition,
Yeah.
yes or no?
Yeah.
It's
Anti.
Oh, it's anti-Markovnikov.
Mechanical.
Yeah.
Yes.
I remember something about Markovnikov. 2, 3. This is anti-Markovnikov.
Yes.
So that means that the hydrogen is going to go here?
It's gonna go where the most functional group is.
No.
Hydrogen.
I never said this in class. I don't know where you're getting that from.
More
You
substituted
invented
carbon.
this.
Anti-Kornikov goes to the one with
The most
least amount, least
With the
amount
least
of
amount of
hydrogen.
hydrogen.
Yeah, the most substituted
Okay.
carbon.
So anti-Markovnikov says that the hydrogen will go to the one that has more,
Substituted
Functional
carbon.
okay, more substitutions or, I
Least
don't know
amount
what
of
functional
hydrogens.
groups means, not functional groups.
Least amount of hydrogen.
The least amount of hydrogens, right? Most amount of hydrogens, that's
That's what
Markovnikov. So the hydrogen will go where? Here?
Yeah.
Hydrogen will go there.
Yes.
And the OH is going to go here.
Yeah.
Yes or no?
Yeah.
That is what happens when you do hydroboration oxidation. Now, of course, this is called an enol. And we have already done this, yes? Yes or no?
Yes.
An enol undergoes what?
Tautomerisation.
It doesn't matter if it's right or not, because I don't know if I'm pronouncing it right. Because I don't remember when my professor pronounced it, because I was like you guys. Never studied until I failed. So it will undergo tautomerization. This is called the enol tautomer. And it will undergo tautomerization to form the keto tautomer. Which one is more stable? Keto.
Okay, so.
So you are diluting this from keto to keto. All right, so the double bond to the oxygen is going to be formed here. There it is, double bond to the oxygen. What does this have here? An H, and this carbon here is going to have
CH.
CH2, and then there is another CH2, and then another
CH2 and
CH2.
CH3.
and then a CH3. Outstanding. This is an aldehyde. You get an aldehyde if you have a terminal alkyne and you do hydroboration oxidation. Can you form an aldehyde from oxymercuration, demercuration?
No.
Hello?
No.
Why not?
Because see.
La viste, why not, man? What do you mean, what?
What you said is God didn't make it that way.
Well, yeah, you're right. Still gonna get you no points on the test. If I do oxymercuration, demercuration here, my Kornikoff addition says that the alcohol, the OH will go to which carbon? To this carbon. And that could never give you an aldehyde. It will always be a ketone. So if you do hydroboration oxidation to a terminal alkyne, you will get an aldehyde. If you do hydroboration oxidation, I did this last class, didn't I?
You did.
And it was so long ago, we don't care, huh?
No, well, sort of.
Sort of, no.
You only gave one example.
Okay, well, how many do you want? 20?
No.
Okay, so you want one next to this one then? Okay. You guys got issues, let's work on those issues. Let's say Ag, SO4, and what else? H2O? What does that give you? This is
Oxymercuration.
kind of oxymercuration. I mean, it does have a mercury, yes? Addition of water in the presence of mercury. This is not precisely oxymercuration, but you can think of it that way. The intermediate here, how do you think is going to look like?
AC
The OH
plus.
is gonna
The
AC
intermediate is going to look like what? It's
Yeah,
going to
the
look
AC
like
plus,
a
right?
mercurinium ion,
Mercurinium,
yes? It's
yeah,
going to
AC
look like the
plus.
three. Okay, good, outstanding. And what we are going to have is, once again, we're gonna have a double bond in this. Is that right or no? Hello?
Yeah.
Where's the OH going to go?
With the most functional
Gauche.
on the left.
Where's the OH, man?
Where's the OH?
Where is it going to go?
With the more substitution.
On the right or on the left? The OH is going to go on the left. The reason why it's going to go on the left is because this is
Kornikoff.
a Kornikoff addition. It had a hydrogen here. The other hydrogen will add to where there is more hydrogens, which means there. And the enol is going to undergo, once again, tautomerization to the keto form. So, double bond to this. What are you going to have on this side? CH3. And then you are going to have this thing there.
Professor, you said when we do hydroboration oxidation for an alkyl, we get an aldehyde?
Alkyne.
For an alkyne. When do we get a ketone?
You don't, look, that raises a ketone. Why can't you see? You're blind? Are you diabetic? I mean, I don't know, how can you not see? You have eyes? What's wrong with them? Sit here. If you get closer, can you see? You're not ready.
Stop talking to me.
Hey, zoom in on her, man.
No. I know.
All right. Apparently everybody gets red. All right, what else?
So this is enol and that's the ketone?
Yeah, guys, this is keto, yes? Is this not keto?
Yes.
This is the aldehyde. This is the ketone. Let's make this clear, okay? This is the enol, and this is the keto tautomer. Keto because it has this functional group here, which is a carbonyl. But when it has a hydrogen, it's called an aldehyde, and when it has another carbon, it's called a ketone.
So why does it say ketone at the bottom on the top example?
You did not just hear what I just said?
There was a lot of giggling.
Why is there a giggling? Someone,
I don't think
Tickling
it's
you?
funny. I wasn't giggling.
I'm gonna say this again, okay? Terminal alkyne, yes or no?
Yes.
Terminal alkyne.
Yes.
Did you write this on your notes, terminal alkyne? Or are you waiting for me to write it on the board? You wrote it, yes? Terminal alkyne. You do hydroboration oxidation, what do you get? An aldehyde. And when you have a terminal alkyne and you do what we are referring to oxymercuration, demercuration, but it's not, right?
Yeah, it's not.
It's not. This is not. Why not?
We have the isolate.
Wait, the bottom.
Yeah, because the reagents is not it, yes? In oxymercuration, demercuration, we have mercury acetate. We have the water, and what else do we have? A reducing agent, right? Sodium borohydride or no?
Yeah.
Yeah.
Okay. Here, we don't have this. Here, we have this mercury, which is going to add to this triple bond here, and it's going to form this thing here. Okay? And there is a double bond there. The double bond is going to get attacked on the other side with this water, and you are going to have the enol straight. Okay? So there is no need to do oxymercuration, demercuration, because you're going to have a mess here. So, this is called the enol because it is an alkene with a what?
Alcohol.
With an alcohol. So, enol. Enol. Now, this here is what makes this a keto tautomer. Keto here, keto there. This keto is not because it's a ketone. It is because it possesses this carbon-oxygen double bond. That's why it's called keto. In this case, this carbon-oxygen here has a hydrogen, so that's called an aldehyde. Here has another carbon and a carbon there. It is called a ketone. How's that? Why are you sitting there? Don't you sit there?
No, because I can see better here.
Oh, really?
Yeah.
You didn't think I noticed this type of thing, did you?
I didn't notice. I know you were going to notice.
I notice everything, okay? I'm like a jealous girlfriend, huh? Should be looking at the fingerprints you got on your phone. Who you been calling on your phone?
Oh, man.
All right. That's good for that. What else do you want? Huh? Did we do hydrogenation to this?
No.
Hydrogenation?
No. We did hydrohalogenation. We did not do hydrogenation.
No?
We did hydrohalogenation.
I don't believe you.
Hydrohalogenation.
Guys, stop giggling, okay?
So we did hydrohalogenation. Hydration.
That's it? What have we been doing in this class? There's no material being taught in this class. No wonder everybody gets an A in this class. Let's do hydrogenation.
Yeah, it's here.
You have it? She showed me she didn't have it.
We don't have it.
Of our
For an
kind?
alkyne.
That's not it.
I'm tripping. Do you have it? No, that's not hydrogenation. Oh my goodness.
Guys, there is a difference between halogenation and hydrogenation. Hydrohalogenation means HCl or HBr, yes?
Yeah.
Which gives you what as a product? It gives you vicinal or geminal.
Yeah, geminal.
It gives you geminal dihalide.
Yeah.
If you add Br2, what does it give you?
Give me a
Bisonar or geminal? It's not both.
So you can't tell they're everywhere.
Yes, that's right, you can't tell, they're everywhere. Okay, but if you had a double bond and you do halogenation with Br2, what does it give you? Bisonar dihalide. Okay, here's halogenation. I mean, no, I'm lying. Just hydrogenation. I'm tripping. So, here it is. H2, palladium or platinum, right? And these are catalysts. If you look at my notes from 1046, there is a reaction that I have on the slides that is of this. But of course, you don't even remember what room you took 1046 in.
It was this one.
Yeah, you didn't even take 1046. Well, but you forgot everything, right?
Oh, nice. It's across this, like the room across from this one.
Yeah, I know, but my friend that, okay, whatever.
Is that lead or PT?
Palladium and platinum.
This,
I don't know,
this is
PT?
PT. And this is PT, yeah, this is PT. This is platinum and this is palladium.
Okay.
Guys, so the first part that happens is, you form an alkene, okay? Now, the alkene, can it still react with this?
No.
The alkene can still undergo a reaction called the hydrogenation. So, because there is still this in there, you are going to get a mixture of this stuff, okay? Which eventually is going to become an alkane. So in general, let's say that I have this. CH3 here, CH3 here. And I treat this with hydrogen and palladium as a catalyst. What type of addition is this? This is a syn addition. So both hydrogens are going to add to the same side. You are going to get this. Hydrogen on one side, hydrogen on the other side, CH3 and CH3. What did that give you? That gave you cis-alkene, yes? Yes or no?
Yes.
But since there is a lot of this in there, and now you are forming this, is there a possibility that this is going to react with this? Is there a reason why the chemical should only react with this one and not with that one? No. So a second mole of this is going to react. And normally you cannot stop at this. Normally what you are going to have is this reacts with this to form this, and some of this is going to react with this to form the alkane. So you have a mixture of alkanes and alkenes. So because of that, if I tell you on the test that I am adding excess, or I say 2 moles of this, you are not going to stop at the alkene, you are going to stop at the alkane. Okay? So if I say excess, you can know that the first addition is there, but eventually this will go to
Okay.
the alkane. Then you lose cis and trans once you get to the alkane, right? There is free rotation on those single bonds, like we did on Newman projection.
Sections, yeah.
This is a PD cap, yes? Palladium catalyst. Provide the final product to that. Final product. Oh, I forgot to do the mechanism for the carbines, yes?
Yes.
Let's do it. What? this yet, okay? It's just for me to remember. What's the product? What's the answer to this?
You get an alkene first for the
No,
hydrogen.
give me the end. Yes, it is gonna be an alkene first, with syn addition, and second is going to be
An alkane.
an alkane. I'm just going to write it. How many carbons is this alkane?
3.
1, 2, 3. Okay? Yes?
Yeah.
Outstanding. We have a reaction that can stop at the alkene level. And the reaction is using something called a Lindlar's catalyst. So if I use H2 and Lindlar's catalyst, Lindlar's catalyst, I'm going to stop at the alkene, and this is a syn addition. So you write the product. Guys, did you make the flashcards? You did? How many?
I like 30.
My pack was this big. For organic 1 and 2. Is your pack this big? Half? Not yet, right? What's the answer to this?
Double bond, CH3, CH3, HH.
I don't have to draw the wedge and the dash, right? I can just show it that it says and trans, but we're writing it like that because it looks cooler, yes? When your friends see the notes, when you're doing that barbecue, you're showing everybody what you have learned in my class, that looks cool. They go, oh, what is that? Now you gotta take our next class, you know? This ain't for free. Post it on YouTube and stuff. So, what type of stereochemistry is this? Cis, yes? So this is a cis. And it stops at what level?
Alkene.
At the alkene. One of these reactions that I am trying to teach you, you will see what we are going to do with them. You are going to be scared.
So, Professor, on the test, you want us to use the wedges and the dash, or just?
No, if you don't use the wedge and the dash on the test for that type of question, it's okay. And you do have to show me cis and trans, right? But if it's a cycloalkane, you might have to. I mean, not specifically for this one, because to have a triple bond inside of a ring is kind of messy. But we could have it, okay?
Professor, why did you, on the other one, why did you just write it out like normally? And you didn't do any.
Because
You can do.
you can do whatever you want.
No, I can't just write it down the test.
Yes, you can, why not?
And I just did it.
Of course. You mean, is this an acceptable way of writing chemicals in this class, yes or no?
Yeah.
Yeah, but
Yes.
everything else is structured.
It doesn't matter. Is this an acceptable way of writing stuff in this class, yes or no?
Yeah.
Is this correct?
Yes.
Is this correct?
Yes.
I give you credit. If that's correct, I give you credit. If that's correct, I give you credit. If you write this like this, I give you credit. And if you write it like this, without putting the dash and the wedge, I still give you credit if you draw it cis.
Okay. Gotcha.
Now, the problem is that sometimes I write it like this and sometimes I write it like this. So you have that question you are having now. And so you understand that we can write it whatever way it is. On the test, you might see it like this. On the test, you might see it like this. What other way can you see it?
Line.
You might see it like this.
Yeah.
Everybody is supposed to be old enough and mature enough in this class to notice that this is going to happen to you. That, this, or this. What else, my friends?
Cody.
Why don't we do carbines and relax you a little bit with a little mechanism, huh? Spice things up. You know, get the juices flowing. You know what chloroform is, yes? This is chloroform.
Yes.
If you have a bottle of this chloroform and you put it on a napkin and you put this over your face, you are going to faint. You should do it standing up. Because if you are laying down and it stays over your face, you might die. If you're doing standing up, you're just going to hit your head against the floor. It's no big deal. So this is what happens during this mechanism. I have chloroform. And there's potassium hydroxide in there. So there is OH minus. And of course there is potassium plus, which we don't care about. Yes, potassium is not doing anything. This OH is a what? A base, is it not? Or a nucleophile. And they're similar. And what this base is going to do is it's going to go to this hydrogenate. You're leaving it. And what's going to happen to the two electrons here? Are they going to go with the hydrogen, yes or no? No, they are not. They are going to stay on this carbon. So what you are going to get from here is a carbon that now has these two electrons and the chlorines. The formal charge of this is
Negative.
a negative. Okay? Some people like to circle that negative charge in a little, so you know that this is not a minus but a charge. Whatever, it doesn't matter to me. And now look what happens. These chlorines have electrons. This one decides to say, hey, I'm leaving. And I'm taking them electron pairs. So what is this going to form? Cl minus, yes? And this carbon here that had two electrons now has bonds to what?
Chlorine and
To chlorine and
Another
to
chlorine.
chlorine. What is the formal charge on this carbon?
neutral.
It's neutral. That's right. It's neutral. And this is called a carbine. But if you think of it, this would be what type of formal charge? A negative, yes? And when the other one left, that would have been a positive formal charge. So what this has is, it has an electron pair, and it has an empty p orbit. And that's what makes a carbine. A carbine, or this carbine, looks like this. How many things does it have? What's the hybridization?
SP2.
sp2. This is sp2. Stand. As they say, you don't learn anything in my class. You want to do it like this because it's cooler, yes? You like it like this. Chlorine here, and here you will have the lone pairs. So it looks sp2 with a bond angle of around 120, yes? But what else does it have? This carbon here has an empty p orbital. So the carbene, does it need electrons, yes or no? Does this empty p orbital need electrons?
Yes.
And can these electrons be used to make another bond with something else?
Yes.
Yes. So that is what happens when you have a double bond. You have a double bond. One of these are electrons. So we can do an incorrect resonance structure, yes? In which we put the electron pairs on one, and this is positive, and this is like negative, yes? Yes or no? So the carbene will make a bond here, and these electron pairs will be used to make another bond with what from the carbene? From the anti-orbital. Okay? So, of course, this is not written like that. The carbene is here, with the Cl and the Cl. And what is going to happen is that is going to make a bond, while this will make another bond. And now the result is how's that, guys? Did you like the carbene mechanism? How many mechanisms would you like to have on the test?
None.
5.
I'm not gonna lie to you, you ain't gonna have less than 3.
How many?
Or 5.
You are not going to have less than 3. So you choose. Did you like hydroboration oxidation? That's the one you liked, didn't you? You want that one? Look, let's choose one of the two right now.
Hydrogenation.
Do you want hydroboration oxidation or oxymercuration demercuration? Which one do you want? Hydroboration oxidation or oxymercuration demercuration?
Oxymercuration, demercuration.
Hydroboration.
You want oxymercuration
It's a
demercuration?
demercuration.
Yeah, that's the easy.
Yeah, that's the easy one. Y'all tripping. Whatever.
Oh yeah, whatever. You can decide. You got both of them on the test. Hey guys, can I?
Don't worry, I got it.
Well, you choose.
Go on YouTube and judge.
I don't care anyway. Whatever.
Guys, I'm afraid some of you are not watching the videos. Who's not watching the videos? And you don't think I can see it?
That email you sent with the video, were we supposed to answer that question or just watch the video? I just watched the video.
About
Well, you
people
were
at the
supposed
beach.
to answer the question. That's why I wrote the question. So you can answer.
Like when
And I
I'm
spent, you have no idea how long I spent to learn how to use that.
I was gonna answer, but I was like, oh, if I'm gonna get it wrong.
I do know, but I don't care. So by you not answering, that's when you did it wrong. But that's okay, I still don't. What happened? Okay, well, you're gonna check your grade when it's You're gonna check your grade or not? Well, you should. But you watch the videos though? Really? How many times you watch it? Once? And you get all you need from watching it once? You go to what? And that helps you. Whatever helps you, okay guys? You can go watch the videos of somebody else, you're not hurting my feelings. I got no feelings.